Alright, that was John Lennon, Imagine, classic song right there. You know, we're still doing imaginary numbers here, so I thought I'd throw that in there. This song's all about world peace and whatnot, but if you play it backwards, it's really actually all about complex numbers. Try it out sometime. Excellent. Moving on here, let's take a look at the comics. You know, one of the reasons I like teaching Algebra 2 is like the level of math humor really takes a step up here, so they're pretty hilarious. Let's check out this comic here. Check out, there's Pi saying get real to, hopefully you notice this. What is this? This is I. It's an imaginary number. That's the definition of I. He's saying get real. And he's saying be rational, because remember, pi is an irrational number. It goes on and on and on forever and ever and ever. It never repeats, so it's irrational. So that is pretty much hilarious. 6.4, solving using the quadratic formula. So let's do a quick review here of things we've done. We started off really last chapter. Mr. Sullivan was using square roots to solve it, and he was keeping it real. All his solutions were real. In this one, I kind of added some stuff. I added some imaginary solutions. So we can use square roots to solve quadratics. Mr. Sullivan also looked at addressing factoring, so we can use factoring to solve these quadratics. And in 6.3 we just did completing the square, so I just showed you that one. That's a pretty fun way to do it. So there's a couple different methods, you know, and it's easier for certain cases. You know, sometimes they don't factor, so you got to complete the square. Sometimes it's just set up for the square root. To this time we're going to use the quadratic formula, and you've probably seen this before. I'm going to show it to you again. This one always works. You can always use the quadratic formula and always get the answer. That's pretty cool. And then I'm going to check it on the by graphing on the calculator. So there's going to be a little bit of that. Well, that's kind of weird. This is a video of what's going to happen in the future of this video. That's weird. This is us watching the video ahead of time. I got to get off this page. That's freaking me out. All right. So before we get started, let's talk about this quadratic formula. So you've seen it. There it is. Boom. There's the quadratic formula. Where did this come from? They just make it up? No, it's really just completing the square. So if you leave this generic quadratic, this ax squared plus bx plus c, you can derive the quadratic formula. And that's what I'm going to do for you right now. A lot of times in geometry, I like to say prove it like it's hot. But really, again, Algebra 2, this is not a proof. This is deriving a formula. We're going to take a formula and derive it by completing the square of this. So I'm going to derive it like it's hot. I'm going to do it really, really, really fast. You don't have to take notes on this. I just wanted you to see it to make sure that it is legit. This is a real formula that comes from just manipulating the generic standard form of a quadratic here. So enjoy this. When you need to solve a quad, drive it like it's hot, drive it like it's hot, drive it like it's hot. Solutions are non-real, yo. Graph it like it's hot, graph it like it's hot, graph it like it's hot. Problem's got an attitude. Solve it like it's hot, solve it like it's hot, solve it like it's hot. Alright, so now we know it works. Sweet. Let's go ahead and use it. So let's get rolling on here. Finally some math here. So hopefully we're good with our our A, B, and C. Find A, B, and C. If you want to write those out, you're more than welcome to say, hey, I'm going to label A, B, and C. A is the number in front of x squared, the coefficient. When this case, if it's not written, it's 1. B is the number in front of x, and C is the constant. Whoa, whoa, whoa. Before I can name that, what do I have to do here? I have to set it equal to 0. So I kind of got a little bit ahead of myself. I have to subtract 2 from both sides. So I'm really looking at x squared plus 3x minus 2. Only works when you set it equal to 0. So be careful there. Now I know C is a negative 2. So I've got my A, B, and C. I'm ready to use the quadratic formula. So this is just really a matter of plug and chug. I love it. So let's plug these in. I've got B is 3. So this is looking like a negative B plus or minus the square root of what? B squared minus 4 times A times C. And that's all over 2A. So I'm going to give you this formula whenever you need it, but you'll probably use it so much that you'll memorize it just from using it. So how do we simplify this thing? Well, we're going to simplify underneath that square root first. So it's plus or minus the square root of what? 3 squared is 9, minus 4 times 1 is 4, times 2 is 8, and since it's a negative times a negative, it is plus 8, and all of that is over 2 times 1, which is 2. So not bad. So really, let's break this down a little bit more. What is this going to equal here? So I'm going to bring it down over here. Negative 3 plus or minus the square root of 17 all over 2. Great. So what does that mean? This is fantastic. That is the answer. This means you've got negative 3, add square root of 17 to it, all over 2 is 1, or negative 3 minus the square root of 17 all over 2. So that is my solutions here. So I was going to check it graphing to make sure I did this right. So this is pretty fantastic right here. How do I graph this thing? Well, let's just go ahead and graph it first the old school way. Remember back with Mr. Sullivan, you could find the x-symmetry by saying negative b over 2a. So I can do the same thing here. Use your same a and b. You know, it's all the same thing. So if I look at negative 3 over 2 times 1, I'm looking at my axis of symmetries at negative 3 halves. So negative 1.5. I know it's cutting the parabola in half. And then I'm saying, okay, I want the vertex. So if the x is at negative 3 halves, where's the y at? So plug that back in here, and we're looking. Alright, so what I like to do once I have find the x-symmetry is negative 3 halves, I like to put my equation in the y equals, and I'm going to kind of do a little shortcut. Yeah, I want to plug negative 3 halves or negative 1.5 in there, but check it out. If you use the table feature over here, it saves you some work. So right now I'm in above window, it says table set. If you come up here, I have changed my independent variable to ask. Instead of auto, I'm going to ask it questions. Auto's fine, it fills in the table for you, but if I'm going to ask it, now check this out, I'm going to ask it negative 1.5 or negative 3 halves, and it's going to tell me the answer. I love it. So at negative 4.25, that's where this thing's going to go. So really, I can say, sure, I know this now. This is at negative 4.25. So what's good about that is that's where, this is where my vertex is. So all that work was to find the vertex. From here you can do your 1, 3, 5 rule. So it's going to be up 1. It's kind of weird because I'm in the halves here, but no worries. Then from that one I'm up 1, 2, 3. So I'm something like this, and it's symmetric. So I've got it over here and over here. Draw that bad boy in. So I can get a pretty good graph just from what we did last chapter. Awesome, very good. So there's my parabola. So I want to know these solutions. Are these solutions, did I solve this? Well, here are my 2 solutions. There's one and there's the other one. So this root right here, where it crosses right here, boom, should be negative 3 minus the square root of 17 over 2. Now that's not a number I really know off the top of my head, is it? That's kind of a weird number. So let's put in the calculator. So use parentheses if you're going to do it in one line. I usually do it in 2. I usually say negative 3 minus the square root of 17. And I want you to be able to do this. I want you to be able to find the decimal form. So we have the exact form. There's the decimal form. If I do, well, then what do I got to do? I'm sorry. If I subtract them on top, then divide it by 2. So it should be at negative 3.56. And then if you want to do it this way, if you want to do it in one step, you can't go negative 3 plus the square root of 17. Just make sure you're dividing the whole top. So use those parentheses. That's divided by 2. I don't care how you do it, as long as you get the right answer. So here are my 2 answers. So check this out. This is the decimal form. So these are the approximations of this. Do they match up? Does that look pretty good? Is that negative 3.56? It looks like negative 3.56, so I did a nice job. That's negative 3.56. Is this other one at 0.56? Looks like it. This is going to be 0.562, or if you want to round it to 3 decimal places. So that's my other root. So we're actually going to label these things on here. I want you to be able to give the decimal and the exact. This is negative 3 plus the square root of 17 all over 2 is this root right here. So they are the solutions. That's where it crosses. Awesome. So the calculator is pretty great for that. Actually, the calculator is even better than that. What if we would graph the whole thing? You know, I already had in my y equals. What if I just graph it? There, I know I did it right. So will it give me these roots or these solutions? Sure, no problem. I'm going to find what? I'm finding the zeros. I'm finding the roots. So if you haven't done this before, we have the 2 roots up here. So I'm going to find the left one first. So you kind of got to trace over. I kind of put my thing as close to the root as I can. So I'm not exactly on it, or else this would be y equals 0. But I've got this left bound. It wants a left boundary because you have 2 roots. You can't just hit enter and it finds them. It needs some boundaries here. So if I hit left a couple times, maybe 3 times, now I'm left of it. So it's going to set the boundary left. Now it wants a right boundary, so you need to get right of that root. So I go back to it, then I hit right a couple times, and I hit enter again. So it's looking between these 2 arrows here for the root, and there it is. It wants you to guess, but you don't have to. If you want to guess, you try to get right on the root. Hit enter, boom, and what does that tell us? It tells us what? One of the roots, and we knew that, didn't we? Isn't that what we said? We said negative 3.561. We rounded it, boom, there it is. So that'll hook us up. Can I go back and find the other one? Sure, do the same thing. Go back to second trace. We're finding the zeros, and now come over to this root. So again, I come up on this root over here. That's where I think it is, and it wants the left boundary, so hit left like 3 times. And again, it's not up or down, it's only left or right. I don't care if it's above or below. I'm going left and right of the root. So now the right boundary, hit right a couple times. Then guess it. Boom, 5.61. I hope that's what we said. Is that what we said? It is exactly it. So these are approximation because they're decimals. These ones with the radicals and these fractions are the exact. So I want you to be able to do both. Calculator is a great way to check. You could even check the vertex if you want to find the minimum point and make sure your vertex is right. Awesome. I love it. That's the quadratic formula. Nailed it. All right, so let's go ahead. A lot of these answers we're going to need to simplify more. The last one was pretty as far as I could go, but sometimes they break down. What I really like to do with these is break them into 2 fractions. This is going to be 4 over 6 plus or minus radical 8 over 6. So you don't have to do it. This is just one way to do it, but I really like this method of doing it, and I'll show you why right here. So that's square root of 8. So if it's 2 fractions, I can just reduce the first fraction. What is 4/6? Yeah, it's 2/3. I just reduce it. No problem there. What's the square root of 8? Well, I got to break that down into square root of 4 times the square root of 2 all over 6. And that's good, but what is the square root of 4? That's right, we've got 2 radical 2 over 6. Does that reduce? Sure, so just like I reduced 4/6, now I'm reducing 2/6. I'm reducing the number here, not the radical. So this goes into it once, it goes into it 3 times. So I'm really looking at 2/3 plus or minus, what is that, 1 radical 2 over 3. Excellent, and please remember that is 2 answers, you know. That is 2/3 plus radical 2 over 3 is 1 answer, or 2/3 minus radical 2 over 3. These are 2 distinct solutions here. So the plus or minus, sometimes people get caught up in that, but it really means, you know, you've got these 2 possible answers. And again, we can make those decimals if we want to. Awesome. How about the middle one? So this is going to happen to us. So if I split it into 2 fractions, I get 5/2 plus or minus. Ooh, when I square root this, what is this? It's imaginary. The square root of negative 24 is what? I radical 24. And is that going to break down? I think it is. 24 breaks down into what? It breaks down into 4 times 6 all over 2. And then I'm going to say, so I got my 2 fractions here, and I'm going to say this is what? Square root of 4 is 2. So 2i radical 6. And then again, I can cancel out my I, or not my i's, my 2's right here. So I'm really looking at 5/2 plus or minus, this is I radical 6. Awesome. And again, it's 2 solutions. It's 5/2 plus I radical 6 and 5/2 minus I radical 6. Awesome. Boom and boom. And again, I can make that decimals, but now it's a complex number, so I can't combine them. So I'm not going to get 1 decimal. I'm going to get 2.5 minus some crazy decimal I. Maybe we should do that one. Let's do that one. Just so we see what that looks like, because that could be weird for we haven't done much of this. If we look at this, this is going to be, if I clear all that out, 5/2, so it's going to be 5/2, which is 2.5. So I know that one. It's this radical 6 I don't know. Square root of 6. What is the square root of 6? So if I tried to write this as an approximation, it would look like this. It would be 5/2 is 2.5 minus, what was that number? 2.449. So it would be 2.449i. So you could write that. That is the same thing. That's just the decimal approximation of the exact value. And do the same thing with the plus. You can do plus or minus. Awesome. Let's do the last simplification. Let me show you a common mistake that we as math teachers always see is people love to do this. Don't do this. This is wrong. Boom. They think they're done. 2 plus or minus radical 17. No, this is like nails on the chalkboard for him. Ooh, did I really put that in there? You may need to rewind that, listen to that a couple times. That is wrong. Oh, that is wrong. Don't do that. Do not do that. What do we really do? We're going to split this into 2 fractions, and sometimes you can't really do much with these. Well, the first one reduces, doesn't it? This is 2 plus or minus, and then we're done. Radical 17 over 2. So that's it. So sometimes there's not a lot going on here, but that's cool. We're okay. We're good to go. Fantastic. Moving on. All right, so let's solve some of these quadratics. Check them, see how we did. All right, so the first one, again, you want to get it so it equals 0. So if I'm going to move my 4x's over here, I've got negative x squared plus 4x equals that 5. I need to bring that 5 over real quick, so I'll bring the 5 over. Boom. We've got this. So the reason I picked this one is I hope something interesting happens here. So if I find my a, b, and c, A in this case is what? Negative 1. Remember there's a 1 in front there. B is now 4, and C is negative 5. Plug these bad boys in here, and I get what? You get negative B plus or minus the square root of B squared minus 4. A is at negative 1, be careful, and C is negative 5. So all of that's over 2A. And the reason I did this, oh, is anything weird happening here? Well, I know it's negative 4 plus or minus. What's going on in the square root? We're looking at what? 16 is the squared, and then minus times a minus times a minus. Oh, that's still minus. Uh-oh. So 4 times 1 times 5 is 20. Check that out. What is happening here? You got a negative 2 on bottom. That's right. We're going to get a negative square root, aren't we? So this is negative 4 plus or minus the square root of negative 4 all over negative 2. Can we simplify this? Sure. Just like we just got done doing. Split this into two fractions. This is negative 4 over negative 2 plus or minus. I'm going to go ahead and what? Square root that. What do you get when you square root negative 4? You get 2i. And all of that is over negative 2. So I'm pretty good simplifying. Let's go ahead and finish this out. Negative 4 divided by negative 2 is positive 2. This is really a strange concept going on here, though. We've got positive 2 divided by negative 2. That's negative, but if I'm plus or minus a negative, does that matter? It's not going to matter what the sign of this is, because if you minus it, you're going to minus a negative, which is just like plussing. If you plus it, you're going to plus a negative, which is just like minusing. So it doesn't matter. I don't care what the sign is. We're going to call it just regular old 1i here. So really, this is the best answer here, 2 plus or minus I here. So if you said negative I, I mean, you're not wrong. It's just weird. You know, you're saying plus and negative, which is like subtraction. So I don't know. I don't worry about the sign in the second one because of that plus or minus. You don't need it there. Very cool. Awesome. What does that look like graphically? Well, if I go to graph this bad boy, so check out the graph of this one. So there's the graph of it. Boom. I've got this is the graph. Yeah, they're imaginary roots because it doesn't cross, right? It's not going to ever cross. So that's why it doesn't have any solutions here. So we can get imaginary ones. Awesome. Try the next one yourself. See how it goes. Pause it. I'll put up the answer. Good luck. All right, here we go. So kind of some big numbers in this one. A couple of things to highlight here. Check this out right here. This is another big common mistake. Again, like the nails on the chalkboard. At least I give you a warning there. Negative times a negative is a positive, so put in parentheses, especially if you're using your calculator. This is parentheses. Negative times a negative, definitely positive 900. So that's interesting. Also, this negative b in front. When you have a negative negative, that's a positive, so it becomes plus 30 out there in front. When I simplify this down, I got 0 underneath my square root. That's pretty wild. So that's 0. What's the square root of 0? Yeah, it is 0. So if you break it down in 30 plus 0 over 50 or 30 minus 0, well, it doesn't matter. You get 3/5. So there's one solution here, and check out the graph. Why? Because it touches one time right there. See how it's only touching one time? So that's pretty cool. So you can get 2 solutions, no solution, 1 solution. Awesome. So that's a great segue into this. So because of that, we have this thing called the discriminant here. So what does the discriminant mean? Well, it's going to help us find some different things here. So what is the discriminant? It's really this area underneath the square root. Boom. We're looking underneath the square root. So if I have a discriminant and it is greater than 0, that's a fancy way of saying your discriminant is positive. So if you get a positive number in there, you know, if I just make one up like 2 plus or minus the square root of 12 over whatever, 4. Doesn't really matter. If I get this, what's going to happen? How many real solutions am I going to have? I'm going to have 2 real solutions here. And what is that graph going to look like? Well, if I graph it, it's going to be, I don't know if it probably opens up or down, depends on the original, but it's going to look something like this because it crosses 2 times. So when your discriminant or the area underneath the square root is positive, you're going to get 2 solutions. What about if the discriminant, that part underneath the square root, is less than 0, which means that's just a fancy way of saying it's negative? What happens if I try to do one and I got 2 plus or minus the square root of negative 12? This just happened to us, didn't it? If that happens, I get no real solutions. There's none, but keep in mind you're going to get 2 imaginary. So you will get 2 imaginary solutions in this case. So no real solutions. And then graphically, what does that look like? Where do they cross at if I graph? Well, they don't. Maybe it looks something like this. It never crosses. They're just imaginary roots there. Awesome. And then the finale, what else? So I've got positive, I've got negative. What happens if it actually equals 0? That's the one I just did for you here. So this is a fancy way. What if there's nothing positive, negative? This is if it equals 0. If it equals 0, how many solutions? You're going to get that 1. It's that special case where you actually only get 1 solution. Why do you only get 1 solution? Well, the key is not that it opens up or down or anything like that. It's just that it touches 1 time. See how it's 1 root? So there's your 1 root no roots, 2 roots. So the discriminant is useful for finding that. Awesome. Very nice. So can you do it? Let's do one together, and I'm going to end you with the last two. See if you can get them yourself. Still with our A, B, and C thing. You know, if you can skip that, go ahead and skip it. But if you want to write these down, maybe it helps you out. No worries. A, B, and C. I know them right there. 2, -3, and 15. I'm only caring about the what's underneath the square root. So it's the discriminant. So I'm looking at just b squared minus 4ac. That's all I care about. Forget about the rest of it. So again, there's that negative b. Ooh, what color is that? I don't think that shows up. Let's get rid of that. Let's get a color that maybe shows up better. -3. Now let's get some handwriting that shows up a little bit better. All right, -3 squared minus the 4 minus the a minus the c. So we're only looking at what is happening underneath that square root. I've got 9 minus, what is 8 times 15? That's 80, 120, I think. So 9 minus 120 in this case would be what? 111. There's my discriminant. I found the discriminant. What does it tell me? Because I want to know what type of solutions. Uh-oh. I'm going to have no real solutions, and really I'm going to have 2 imaginary. So I want you to write, yeah, I'm going to have 2 imaginary solutions. Awesome. Pause it, try the next 2, see what you come up with. Good luck. All right, here we go. So the second one is what? I got 0 in there, so that means there's 1 real solution. It touches the graph 1 time. And then the last one over here, make sure you solve it for, subtract that 9 because it only works when it equals 0. Again, the discriminant was 45. That's positive, so it means there are 2 real solutions. Crosses twice. Awesome. That's everything about quadratic formulas. I'm feeling pretty festive here. If you're on pace, it's right around Christmas here, so I've got a little Christmas algebra video here. I hope you enjoy that. Good luck on the mastery check. Peace out. Just want to give a quick shout out here to Dr. McMullen. She is our Kaiserslautern superintendent. She's an amazing person and has been beyond supportive of the algebras here as we kind of transition into this flip mastery world. Can't say enough good things about her and what she has done for all of us in the district. We're lucky to have her here, so I threw in our little ending clip here as a way to say thank you.